Here, if you notice the arrow, in this guy we have a single head arrow landing on both carbon. But here, a double head arrow is placed on one, which means the two bonding electrons that this bond is having, bond fission or bond cleavage is a breaking of bonds. Is a breaking of bonds. I'm just giving us a layman definition. Bond fission or bond cleavage is the breaking of bonds. We have two types of bond breaking in organic chemistry. We have two types of bond breaking in organic chemistry. The first one is homolysis, which is homolytic cleavage. And the next one is heterolysis. Heterolytic cleavage. Now let me explain this before I detect, so in case of exams you don't have to cram the definitions. Always try to understand terms before cramming. Homo simply means same. Anytime you see lysis, lysis means breaking. Alright, lysis, breaking. Homo, breaking the bond such that the two fragments are retained equally. Now look at this. If I have this, every bond contains two electrons, one on one side and one on the other side. If I break this bond homolytically, I'll do it in such a way that each of these two carbons retain one electrons. So the arrow, we normally use one head arrow. So the product of this becomes C dot plus C dot. It means that the two bonding electrons are shared equally after the bond has been broken. But if I have something like this, a two-head arrow, which means all the electrons that is belonging to this is placed on this other carbon, leaving this guy deficient of electrons. That is a concept. In this case, the bonds are broken such that each of the carbon retains one. That is why we have one head, this guy takes one, and this guy takes one. In this case now, the two electrons are placed on one, leaving this guy deficient of electrons. So the product of this guy would be, the one that is lacking electron will have plus. In our basic understanding of chemistry, anytime an element or an atom is bearing positive charge, it means this guy have lost electron. Is it not so? Now we have plus C minus. So this guy have lost electron and this guy has gained electrons. Alright? So that is basically the concept of bond breaking. Homolysis, breaking the bond such that the two atoms retain one electrons. Here, one of the atoms takes two electrons, leaving this guy without any. So please put down. Let's look at the first one. Homolysis is a form of bond cleavage in a symmetrical way. Full stop. Please put down. In homolytic cleavage, one electron remains with each product fragment. In homolytic cleavage, one electron remains with each product fragment. Now, do not forget that anytime you hear bond, bond is basically what joins two atoms together. So when you see covalent compounds would have more than one covalent bond. So this is a bond. Every bond contains two electrons. When I break these guys symmetrically, I mean that one electron belongs to one and one belongs to one. That is why we said, in this case, one electron remains with each product fragment. Now the product here is C plus C. So we have one electron here and we have one electron here. Class, do not forget that. Don't write this one. I'm going to detect. This stuff is called a free radical. It's called a what? A free radical is basically an atom or a compound that has unpaired electron. This electron is seen as unpaired because it's how many? One. Please put down. Each fragment is called a free radical. Each fragment is called a free radical. Full stop. Please put down. Free radicals are atoms or species with single unpaired electron. Free radicals are atoms or species with single unpaired electron. There are species with single unpaired electrons. Like what we have here is free radicals. Now, but how can question be asked based on this? Let me tell you. They will say the form of bond breaking that gives rise to free radicals is called dash. What is the answer to that question? So please anticipate what problem. I can't really think of many right now, but anticipate what problem. Now the next one is heterolysis or heterolytic cleavage. In heterolysis, bond is cleaved in an unsymmetrical manner or way. The bond is cleaved. Cleave is something as broken, full stop. In this bond cleavage, the two bonding electrons remains with one product fragment. The two bonding electrons remains with one product fragment, leaving the other fragments electron deficient. The two bonding electrons remains with one fragment, leaving the other fragments electron deficient. Note, the product of heterolysis is carbocation and carbanion. The product of heterolysis is carbocation and carbanion. The product of heterolysis is carbocation and carbanion. Carbocation is carbon that has a positive charge. A carbanion is carbon that has a negative charge. Now, like I keep saying, if you really want to know somebody that is chemistry inclined and somebody that is not chemistry inclined, use this guy, tell them to pronounce this. Somebody that is not chemistry inclined will pronounce it as carbocation. And the person is not wrong. The person is correct. But somebody that is chemistry inclined will call it what? So now look at this. In the case of heterolysis, these two electrons present here, if you notice the arrow, in this guy we have a single head arrow landing on both carbon. But here, a double head arrow is placed on one, which means the two bonding electrons that this bond is having is pulled towards this guy, leaving this guy without electrons. So the product of this becomes the side that took the two electrons becomes negatively charged, and the side that is losing the electron becomes positively charged. Now, how can they ask a question on this? Number one, symmetrical. You need to understand the symmetrical. Heterolysis cleave or breaks bond unsymmetrically. This guy breaks or cleave bond symmetrically. It's not so. The products of homolysis are free radicals. What are free radicals? Atoms or species that have unpaired single electrons. The product of heterolysis is carbocation and carbanion, right? One of them has two electrons and the other guy is deficient of electrons.